Top 1 Thorium reactors. In the 1950s and 1960s, researchers in the United States explored thorium reactors as a safer alternative to traditional uranium nuclear power. Early experiments suggested thorium could produce abundant energy with less long-lived radioactive waste. Engineers believed this overlooked fuel might reshape the future of nuclear power, offering a more sustainable and potentially global solution to growing energy demands. Thorium itself is not directly fissile, meaning it cannot sustain a chain reaction on its own. Instead, inside a reactor, it absorbs neutrons and transforms into uranium-233, a fissile material capable of producing energy through nuclear fission. Experimental molten salt reactors dissolved thorium fuel in liquid fluoride salts, which operated at atmospheric pressure and high temperatures. This design reduced the risk of explosive pressure buildup and allowed continuous removal of waste products. Engineers monitored neutron flux, heat exchange systems, and salt chemistry to maintain stable reactions. The molten salt also acted as both fuel carrier and coolant, simplifying reactor structure compared to solid fuel rods used in conventional reactors, while enabling rapid adjustments to reactor conditions for maximum efficiency and safety. Thorium promised advantages: greater fuel abundance, reduced risk of meltdown, smaller quantities of long-lived nuclear waste, and an inherently safer reactor design. Some designs also made it more difficult to divert materials for weapons use, highlighting its potential for peaceful energy applications. Despite promising tests, funding shifted toward uranium reactors that supported weapons development in existing infrastructure. Thorium research declined and was largely shelved. Today, interest has returned in several countries with pilot projects and experimental reactors exploring its potential. But large-scale commercial thorium power remains unrealized, leaving it as one of nuclear energy's most debated and intriguing alternatives, still capturing the imagination of engineers and scientists worldwide. Top 2 Liquid breathing. In the 1960s, scientist Leland Clark experimented with liquid breathing, a technique using oxygen-rich perfluorocarbons to allow humans and animals to breathe liquid instead of air. Early demonstrations with animals revealed that lungs could absorb oxygen directly from the liquid, suggesting the potential for underwater exploration, medical applications, and extended survival in extreme environments. The idea sparked both excitement and ethical debate as it challenged the fundamental limits of human physiology. The technique works by filling the lungs with a specially engineered liquid that dissolves large amounts of oxygen and carbon dioxide. When the lungs inhale this fluid, oxygen diffuses into the bloodstream, while carbon dioxide is expelled back into the liquid, which is then replaced or recirculated. Perfluorocarbon liquids are chemically inert and non-toxic, allowing extended periods of immersion without causing tissue damage. Researchers have experimented with cooling the liquid to induce therapeutic hypothermia, protecting organs during surgery, and even enabling deep-sea diving without traditional gas mixtures. Precise control of fluid composition, pressure, and breathing cycles is critical to prevent lung injury and ensure adequate gas exchange. Liquid breathing offers remarkable possibilities for medical procedures, deep-sea exploration, and survival in environments where air is unavailable or hazardous. It demonstrates how innovative thinking can overcome natural physiological limitations. Although human trials remain limited and risky, the research continues to influence medicine, diving, and emergency response technologies. The concept remains both a daring scientific experiment and a glimpse into the future of extending human capabilities in extreme conditions. Top 3 Concorde. In 1969, Britain and France unveiled Concorde, the world's first supersonic passenger jet capable of crossing the Atlantic in under 4 hours. When it entered commercial service in 1976, travelers could fly from London to New York at twice the speed of sound. The sleek Delta Wing aircraft became a symbol of luxury, speed, and technological ambition. Concorde achieved supersonic travel using 4 Rolls-Royce Olympus turbojet engines, as equipped with afterburners for takeoff and acceleration past Mach 1. Its slender fuselage and sharply swept delta wings reduced drag at high speeds, while a drooping nose improved pilot visibility during landing. As the aircraft cruised at Mach 2, air friction heated the outer skin to over 120 degrees C, causing the fuselage to expand several centimeters mid-flight. Specialized aluminum alloys handled the thermal stress, and complex air intake systems carefully slowed incoming air before it reached the engines. Engineers constantly monitored fuel transfer systems that shifted weight during flight to maintain balance and stability at supersonic speeds. Concorde represented a breakthrough in commercial aviation, proving that routine supersonic passenger travel was possible. It became an icon of prestige, serving celebrities, executives, and world leaders, while demonstrating advanced aerospace engineering. However, high operating costs, limited seating capacity, sonic boom restrictions, and environmental concerns restricted routes and profitability. After a fatal crash in 2000 and declining demand, Concorde was retired in 2003. It remains one of aviation's most ambitious achievements, a bold leap forward that proved speed was possible, but sustainability was another challenge entirely. Top 4. Vanta Black. In 2014, Surrey Nanosystems unveiled Vanta Black, the darkest material ever created, capable of absorbing 99.96% of visible light. When applied to surfaces, it creates the appearance of a void with edges and contours disappearing from view. Demonstrations stunned artists, engineers, and scientists alike as everyday objects seem to vanish into absolute blackness. Vanta Black is composed of vertically aligned carbon nanotubes, microscopic tubes of pure carbon grown on a substrate. When light strikes the surface, photons become trapped between the tubes, bouncing repeatedly until they are converted to heat and absorbed. The material structure prevents reflection, giving it the visual effect of infinite depth. Applied coatings require precise deposition under controlled temperatures and vacuum conditions, and the nanotube layer is extremely delicate, often protected by additional layers for practical use. Engineers have used it to reduce stray light in telescopes, improve infrared sensors, and even explore military camouflage applications. The material revolutionized optics and artistic expression, offering unprecedented control over light and perception. Designers and researchers saw possibilities ranging from more accurate scientific instruments to new forms of visual art and immersive displays. While Vanta Black captivates the imagination, its application is limited by cost, fragility, and handling complexity. Only specialized environments and instruments currently utilize it, leaving the rest of the world to marvel at its almost magical darkness. The effect continues to inspire innovation in science, technology, and creative arts, blurring the line between material and visual illusion. Top 5. Iron Lung. In 1928, American engineer Philip Drinker developed the iron lung, a negative pressure ventilator designed to assist patients suffering from polio-induced paralysis of the chest muscles. At the time, polio outbreaks caused widespread respiratory failure, leaving many unable to breathe unaided. Hospitals faced a crisis as conventional ventilatory support was insufficient for severe cases, prompting the urgent development of mechanical solutions. The iron lung is a large cylindrical chamber in which the patient lies with only the head exposed. A motorized pump cyclically changes air pressure inside the chamber, creating negative pressure around the thoracic cavity. When the pressure drops, the chest expands, drawing air into the lungs. When the pressure rises, the chest contracts, forcing exhalation. This mechanical replication of normal breathing allows patients with paralyzed respiratory muscles to survive for extended periods, sometimes weeks or months, until natural function returns or permanent care is arranged. Early use of the device dramatically reduced mortality among polio patients in hospitals worldwide. Entire wards were equipped with iron lungs, and medical staff developed protocols for long-term care, monitoring, and hygiene inside the confined chambers. Despite its effectiveness, the device was large, cumbersome, and required continuous electricity and supervision. Later innovations, such as positive pressure ventilators and portable respirators, gradually replaced the iron lung, though some patients continued to rely on it for decades. The invention marked a milestone in life support technology, demonstrating that mechanical ventilation could sustain patients with otherwise fatal respiratory failure. It also laid the groundwork for modern intensive care units and ventilator design. The iron lung remains an iconic example of engineering responding to urgent medical crises, showing how innovation can save thousands of lives under extreme circumstances. Its legacy persists in respiratory therapy and critical care. Top 6. Project Pluto. Between 1957 and 1964, the United States Air Force developed Project Pluto, an experimental nuclear-powered cruise missile designed to fly at low altitude for thousands of miles. The concept envisioned a weapon that could remain airborne for days, delivering nuclear warheads while emitting lethal radiation along its path. Early tests of its reactor system stunned engineers with raw power and terrifying potential. At the heart of Project Pluto was a nuclear ramjet engine called the Tory reactor. Unlike conventional missiles that carried chemical fuel, this system used a compact nuclear reactor to heat incoming air directly as the missile traveled at supersonic speed. Air entered the front intake, passed through the reactor core, where it was heated to extreme temperatures, then expanded out the rear to produce thrust. The reactor contained thousands of ceramic fuel elements designed to withstand intense heat and radiation while maintaining airflow. Because it required no traditional fuel, the missile theoretically had unlimited range, constrained only by structural limits and reactor durability. Engineers tested the reactor on massive rail-mounted platforms in Nevada, measuring thrust, temperature stability, and radiation output. Project Pluto promised a nearly unstoppable strategic weapon capable of evading defenses by flying low and fast. Its endurance and destructive capability reflected the extreme military thinking of the Cold War era. However, the missile's radioactive exhaust, uncontrollable fallout risk, and advances in intercontinental ballistic missiles made the concept both dangerous and strategically outdated. The program was canceled in 1964. Project Pluto remains one of the most controversial weapons concepts ever engineered, a chilling example of nuclear technology pushed to its absolute limits. Top 7. TR-3B Astra. Since the 1980s, conspiracy theories and alleged sightings have described the TR-3B Astra, a triangular anti-gravity aircraft supposedly developed by the United States military. Witnesses report glowing, silent, triangular craft hovering or moving at incredible speeds, sparking fascination and debate about secret aerospace technology. Photographs, radar blips, and anecdotal accounts have fueled speculation, blending fringe theories with glimpses of advanced military research. Reports suggest the TR-3B employs a rotating plasma core, producing a strong magnetic field to counteract gravity and stabilize the craft. Observers claim it uses exotic propulsion, allowing abrupt accelerations, silent hovering, and near-instantaneous changes in direction. The triangular design allegedly maximizes lift and stability, while onboard systems allegedly shield the vehicle from radar detection. Engineers, if the craft exists, would need to manage enormous electromagnetic forces and energy consumption, balancing stealth, propulsion, and safety in ways far beyond conventional aircraft. Interest in the craft highlights the allure of unexplained technology and the human fascination with breaking the limits of flight. It has inspired aerospace enthusiasts, UFO researchers, and speculative engineering studies. Whether fully operational or purely anecdotal, the TR-3B remains one of the most enigmatic stories in modern aviation. Its legacy is less about confirmed technology and more about imagination, secrecy, and the possibility of hidden advancements just beyond public knowledge. Top 8. Cymatics. In 1787, physicist Ernst Chladni discovered cymatics, the phenomenon where sound creates visible patterns on surfaces. By sprinkling sand on vibrating metal plates, he revealed intricate geometric shapes that formed and shifted with different frequencies. Demonstrations captivated audiences, showing that sound could produce tangible, almost magical effects on matter, bridging the gap between science and art. Chladni's experiments involved applying a violin bow to metal plates covered with fine sand or powder. As the plate vibrated at specific frequencies, standing waves emerged, causing the particles to settle along nodal lines where vibration was minimal. Each frequency produced a unique pattern, from simple circles to complex star shapes, illustrating the direct relationship between sound waves and physical structure. Modern studies have expanded the method using liquids, gels, and digital visualization, exploring how vibrations influence matter at micro and macro scales. Cymatics is now studied not only for artistic purposes, but also for material manipulation, acoustic research, and even therapeutic applications, showing its surprisingly wide impact. Cymatics demonstrates the deep interplay between sound and form, revealing that energy can manifest visually and tangibly. It inspired both scientists and artists, bridging experimentation with aesthetic exploration. Although initially a curiosity, Chladni's work laid the foundation for modern acoustic research and artistic applications. The phenomenon continues to fascinate, showing that even invisible forces like sound can leave visible traces in the world, influencing both science and creative expression today. Top 9. Nimrud Lens. In 750 BC, a Syrian craftsman ground a piece of natural rock crystal into a precise oval lens with optical properties that should not have existed for another 2,000 years. Scientists still cannot agree on what it was for. The lens was discovered buried in the throne room of the Northwest Palace of Nimrud in modern-day Iraq. It measures 38 mm across and was carefully ground and polished to a convex shape, requiring sophisticated knowledge of optics and considerable technical skill to achieve without modern tools. When held up to the eye, it magnified objects 3 times their actual size with a focal length of 12 cm. When held toward the sun at that same focal length, it concentrated sunlight into a point hot enough to ignite material below. Both functions have been tested and confirmed on the original object. The debate is not whether it worked as a lens. The debate is which of those two functions it was primarily built for. 3 theories have been proposed. A magnifying glass for a Syrian craftsman who regularly produced engravings so small they should have been impossible to create with the naked eye. A burning glass for concentrating sunlight in ceremonial fires, or part of an ancient telescope. A controversial theory supported by the fact that Assyrian astronomers demonstrated knowledge of astronomical details that should have been impossible to observe without optical magnification. The British Museum has stated its optical properties were most likely accidental. Yet the lens fits comfortably in the hand, has consistent curvature, and produces measurable magnification. Accidents of that quality do not happen without intention. It sits in the British Museum today, the oldest known lens in human history, still without an agreed explanation after over a century of study. Top 10. Amber Room. Constructed between 1701 and 1709, this chamber of gold, amber panels, and mirrors was originally commissioned in Prussia and later gifted to Russia. Visitors to the Catherine Palace in St. Petersburg marveled at the warm glow, intricate craftsmanship, and shimmering amber mosaics, earning it the nickname Eighth Wonder of the World. Its combination of artistry and opulence made it one of Europe's most celebrated cultural treasures. The chamber was built by joining carved amber panels with gold leaf backing, mirrors, and detailed woodwork. Artisans carefully arranged tinted amber pieces to create subtle gradient effects, while carefully positioned lighting enhanced the natural translucence, giving the space a radiant, almost ethereal glow. Specialized adhesives and mounting techniques maintain structural stability without compromising the delicate design, showcasing the combined skills of cabinet makers, jewelers, and architects at the height of Baroque craftsmanship. Beyond its aesthetic appeal, the room symbolized political power and artistic achievement, representing wealth, sophistication, and diplomacy. It inspired awe and envy across Europe and became a defining example of Baroque luxury and ingenuity. During World War II, the chamber was dismantled and looted by German forces, and its fate became one of history's greatest art mysteries. Today, a meticulous reconstruction stands in its place, while the original remains lost, leaving behind a story of intrigue, speculation, and the enduring legend of a vanished masterpiece. Top 11. Numbers Stations. During the Cold War era, mysterious number stations broadcast encrypted sequences of numbers over shortwave radio, capturing the attention of listeners worldwide. These seemingly random voices, often reading strings of digits or letters, were believed to transmit secret messages to spies behind enemy lines. Amateur radio enthusiasts and intelligence agencies alike monitored the signals, fascinated by their eerie consistency and untraceable origin. The stations operated using high-frequency radio transmitters, sending pre-recorded or live voice sequences at scheduled times. Each set of numbers corresponded to encrypted instructions, decoded only with one-time pads held by the intended recipient. The broadcasts were deliberately repetitive and monotonous to reduce errors, and transmitters were frequently relocated or disguised to prevent tracking. Some stations used synthesized voices while others employed human announcers, creating distinctive signatures to indicate message type or sender. The technology required precise timing, encryption techniques, and secure transmission protocols to ensure that only the target agent could understand the communication. These broadcasts offered a reliable, anonymous method of long-distance espionage without relying on telegraphs, telephones, or other interceptable channels. They became iconic symbols of Cold War secrecy, inspiring curiosity and speculation about global spy networks. Despite the decline of traditional espionage methods, some stations continue to broadcast today, maintaining the mystique of encrypted communication. They remain a haunting reminder of a time when invisible signals carried the weight of international intrigue, and the world tuned in to voices that were never meant to be fully understood. Top 12. Spruce Goose. In 1947, aviation pioneer Howard Hughes unveiled the Spruce Goose, officially named the Hughes H-4 Hercules, the largest flying boat ever built. Designed during World War II to transport troops and cargo across the Atlantic. The massive wooden aircraft stunned spectators with its enormous wingspan and almost mythical presence. On its only flight, it lifted off the water for less than a minute, proving it could fly, if only briefly, and cementing its place in aviation history. The aircraft was constructed primarily from laminated birch wood due to wartime aluminum shortages, using a process called Duramold that bonded layers under heat and pressure for strength. It featured 8 Pratt & Whitney radial engines mounted along its wings, generating enough thrust to move the 180-ton aircraft. The wingspan measured nearly 98 mm, longer than most modern airliners, providing the lift required for heavy loads. Engineers designed a hull capable of operating as a boat with reinforced ribs and internal frameworks to distribute structural stress. Control systems, fuel management, and aerodynamic balance had to account for the aircraft's immense size and weight, making it one of the most complex and ambitious aviation projects of its time. Hughes and his team faced unprecedented engineering challenges, including structural testing, weight distribution, and engine coordination, all under intense public and governmental scrutiny. The Spruce Goose symbolized American industrial ambition and wartime innovation, demonstrating that even seemingly impossible engineering challenges could be tackled with bold design. It pushed the boundaries of aircraft scale, materials, and aerodynamics, inspiring future generations of aerospace engineers and enthusiasts alike. Delays, cost overruns, and the end of the war eliminated its original purpose. Only one prototype was completed, and after its short flight in 1947, it never flew again. Today, it remains a monument to ambition and ingenuity, an aircraft that proved it could rise, yet never had the chance to fulfill its full potential, continuing to capture the imagination of historians and aviation fans around the world. If these stories of forgotten technology and lost wonders changed how you view the limits of human ingenuity, please subscribe and like the channel. We are unearthing the history they tried to bury. Let's plant the seeds of the future together. The next treasure trove will be revealed soon.